Hi, students. It's Miss Arneson. I know you guys are probably getting tired of hearing my voice. You would have that happen in real life too. But the reason that I'm not just putting up any video I find about energy or any website about energy or other topics is because a lot of times the information on there is way more complicated than we need. So I've made this little video about energy because if you look it up on the internet or you watch videos about it, there's going to be a lot to it. And I just want to break it down to its simplest pieces because I think it's easiest to understand that way. Okay, so first we need to define energy, and if you want to, you can write this definition down. The definition of energy is the ability to do work. The ability to do work is the definition of energy. And to me, that's kind of a weird definition because it has another vocabulary word in it that you have to understand. So let's go ahead and figure out what work means really quick, and then I'll tell you about these pictures. Okay, work is when you move something. When something moves is work. And so we have energy to do work. Like that's why we're obsessed with energy. We're trying to do work. We want to make your car move. Well, you need energy to do that. When your car is moving, that is work being done on the car. And how are we doing that? Well, we're using energy from what? Well, from our gasoline, or if we had a hybrid car, we might be using like a battery energy. But we are moving the car with energy. So I always think of clean energy because as a science teacher, I know we really have to prioritize the planet or we're all going to be dying really soon of global warming. These wind turbines right here, they are using the wind, right? It's turning this, and then that's going to generate electricity. And then that electricity can be sent to other people. With the solar panel, the solar panel isn't obviously moving. Sometimes they turn with the sunshine. So sometimes they'll like have their angle follow the sun from the morning to the evening. But there is actually a lot of motion happening here. You just don't think about it. The waves from the sun that these solar cells are capturing, well, waves are moving. So there is work that we're trying to, like we're trying to capture work that's already being done by nature so that we can make it into energy to use for ourselves so that we can do the work we want to do. Like when this energy from the sun gets trapped, we can send it to our house to do the work we want, like turn on our computer, and there's a whole bunch of light energy and waves moving around in the computer and electricity moving around. So even things that we don't think of as work, as moving, they really are. Same thing with you when you're sitting at your desk. This girl's really excited to do her online lessons. You are doing work because your brain is sending electric signals and chemicals around. So you might not look like you're moving very much, but there's still a lot of work going on, and you need energy to do work. And when you run out of energy, you get hungry or you get tired because you need to recharge. All right, let's go to the types of energy. So the two types of energy are potential and kinetic. And I just really like to think of those as, is the energy being used now or is it being stored to use later? So kinetic energy is when something is moving right now. So the airplane is an example of that. Right now, this airplane is moving, and so its energy that it has is kinetic right now. And the other type of energy is called potential energy. This is energy that is not being used right now, but it can be used once you turn it into kinetic energy. That's like a battery, okay? A battery doesn't really have much going on until you turn the device on that you're using the battery for, and then electricity starts moving through the battery, and that means that we've turned it into kinetic energy. So potential energy is stored energy. We're not using it now, we're going to use it later. And kinetic energy is happening right now. The motion is going on, the work is being done right now. So potential energy has the potential to do work, and kinetic energy is doing work right now. It's moving. Okay, here's some examples of this. You can get into a lot of details about any of these, but I'm just gonna basically like define them right here so you know which category they go into. Thermal energy is going to be what you feel as heat. That's a wave, and so it's kinetic. Electricity is a wave, sound is a wave, and radiant energy is also a wave, which is going to be light and heat also count as radiant energy, and so does sound. So some of these can be categorized in more than one way. And then there's also the energy of motion, and that's like literally when like a bird is flying, for example. Potential energy is a little bit harder to understand because it's not doing anything right now. Chemical energy is like what's stored in a battery. Basically, you get a whole bunch of positively and negatively charged chemicals, and then when you turn on your device, the energy gets forced through the battery and kind of like forces this motion through whatever device you're using in the battery. But it doesn't do anything until you turn the device on and make the electricity move through the chemicals that are stored in here. Nuclear energy only happens in nuclear reactions, which are going to be fission and fusion, and nuclear decay. And this is the most complicated one in my opinion, but this is one we're going to learn about more when we start talking about stars. Basically what it means is if you break a nucleus apart, or if you put a bigger nucleus together from two smaller ones, when that happens, a little bit of the matter turns into energy, but a little bit of matter turns into a lot of energy. And then gravitational energy is pretty easy to understand. If you're not moving, but you have a gravitational force pulling on you, which would be anywhere in the universe, then you have the potential to move. And so gravitational energy turns into motion. All right, I think that's all I want to say about that. So hopefully you understand those a little better.